A lot of JEE Advanced problems are multi-concept questions, which implies that the ideas involved or required to solve a problem will not be drawn or derived from just one chapter. It would be a collection of different chapters from different particular units in particular. For example, in this question, beautiful question, second paper, JEE Advanced 2025, it involves parabolic concepts, coordinate geometrical ideas that you have studied, along with applications of integrals, that is area under the curve. So here S denotes the locus of the midpoints of those chords of the parabola y squared equal to x, such that the area of the region enclosed between the parabola and the chord is 4/3. R is the region lying in the first quadrant enclosed by y squared equal to x, the curve S, the lines x equal to 1 and x equal to 4. Then which of the following statements is or are true? Clearly a one or more than one correct type problem. So here, first of all, we have to find out the curve S, and then we have to again apply the concept of area under the curve to find the area of R, the region R. How do we find S is the first question. Now see, S denotes the locus of the midpoints of the chords of this parabola y squared equal to x, such that the area of the region enclosed between the parabola and the chord is 4/3. Midpoints of those chords, immediately you should remember that if there is any conic section given by s equal to 0, not necessarily just a parabola, but any conic section, then you should be remembering this concept that if you have any chord whose midpoint is, let's say, h comma k, then the equation of this chord is given by the form t equals s1. But I believe you should remember, you should have studied that t implies the equation s, for instance, here s in this problem would be y squared minus x. So t would be the expression where y squared would be replaced by y1. In this case, let's call it x1 comma y1 actually. I wrote it h comma k subconsciously because I know that I have to find out locus. Anyway, so if the midpoint is x1 comma y1, then the y squared would be replaced by y1. And 2x would be replaced by x plus x1. In this case, we have only x, so this becomes minus half of 2x, which is x plus x1, replaced by x plus x1. This is the t part, and the s1 part would be simply x and y replaced by x1 and y1, so that's y1 squared minus x1. In our problem, we'll be replacing x1, y1 with h and k, of course, because we're looking for the locus of a point. So this is how we shall be getting the equation in terms of hk and also, of course, xy. And then the question would be to find the area of the region enclosed between that the parabola and that particular chord. And this is where things start getting interesting or lengthy, if you may say so. Let's see exactly how we are going to handle the problem. So, of course, to understand, let us first draw a rough sketch of the parabola, which is y squared equals x, and the chord whose midpoint's locus is required. So let us assume the midpoint to be h comma k. Correct. Now the equation of this midpoint, as I said, can be obtained by applying t equal to s1, which means y squared becomes y1 is k, minus x becomes half of 2x, that is x plus x1 would be x plus h, equals s1 would be y squared is replaced by k squared, minus x would be replaced by h. Correct. Now we are looking to find this area, this shaded region. And see, if you integrate the parabola from 0 to this point first here, and then subtract the triangle so formed, and then here if you integrate from here to here, etc., it's quite complicated, because finding out the coordinates of these 2 points in terms of h comma k seem quite complicated. Instead, what we do is we assume that the endpoints or the extremities of this chord are, let's say, x1 comma y1. and this point is x2 comma y2. And obviously we can assume without any loss of generalization that y1 is less than y2. So now if we draw perpendiculars from these points on the y-axis, of course this is the origin, this is y-axis, then the shaded region can be obtained how? Of course, integrating from y1 to y2, this parabola will give you this vacant space. Ideally, it would have been the white space, but since we are drawing on a black background, the black space. And integrating the straight line, that is the chord, from y1 to y2 would give you the entire trapezium's area. So you're supposed to subtract the black space or the vacant space from the trapezium's area to get this shaded region. Which means, of course, we are supposed to integrate along the y-axis, which means integrate with respect to the variable y and not x. This is the first important concept to keep in mind while solving this question in particular. That means we have to express all our x's in terms of y's. So for the parabola, obviously, simply we say that x equal to y squared, right? And we are supposed to subtract the parabolic curve from the straight lines equation, from the chords equation. So for the chord here, we would now express x in terms of y exclusively. So let's try and do that. Multiplying throughout by 2, we get 2ky minus x minus h equals 2k squared minus 2h. I'm looking only for x, so I'll take the x on the other side and everything else on the left side. Then just rearrange the positions. So x will be equal to 2ky minus h minus 2k squared plus 2h. So basically x becomes 2ky plus h minus 2k squared. So the h minus 2k squared part remains free from x or y. The y terms coefficient is just 2k. So we have got x equal to y squared as the parabolic representation or the equation of parabola in terms of y, and this is the equation of the chord. And therefore this area is given to be 4 by 3. We will get involved 4 by 3 later. First, let us just find out this region's area in terms of h and k, and of course y, I think. So let's call it delta. So this shaded region, let's call it delta. So delta equals integration from y1 to y2, area of this trapezium obtained by integrating this chord's equation, that is x equals 2ky plus h minus 2k squared. From here we subtract the parabola's equation to remove this black space. So minus y squared. Of course, dy. Solving and simplifying, we get integration of 2ky, 2k times y squared by 2, 2 gets cancelled, so this is ky squared. Plus h minus 2k squared comes outside, integration dy is y minus integration y squared would be y cubed by 3. All this within the limits y1 and y2, which becomes k times, when you introduce the limits, it becomes y2 squared minus y1 squared plus h minus 2k squared times y2 minus y1 minus 1/3 of y2 cube minus y1 cube. So of course from here we can see y2 minus y1 can be taken common, and this gives us delta equals, if we take y2 minus y1 common, then we will be left behind with from here y2 plus y1. So this is y2 plus y1 plus simply h minus 2k squared plus h minus 2k squared minus one third of, now that was y2 cube minus y1 cube. So a cube minus b cube by a minus b is a squared plus ab plus b squared. So here it will be y2 squared plus y1 y2 plus y1. So y1 squared plus y2 squared plus y1 y2 is what we shall be left behind with. Now objective is to get rid of all these y1 y2 etc and write it explicitly and exclusively in terms of h and k. How do we do that? We do that by considering the fact that h comma k is the midpoint of the line segment joining x1 y1 and x2 y2. It's the midpoint of this chord, right? So of course h will be x1 plus x2 by 2, which means we have the condition. I would rather write it here. x1 plus x2 equals 2h. y1 plus y2 equals 2k. This is true. Also, don't forget that x1, y1 and x2, y2 lie on the parabola, which means y1 square is x1 and y2 square is x2 as well. So y1 squared is x1 and y2 squared is x2. Right? So now we have to involve, see, y2 plus y1 is 2k. We can replace it here. This remains as it is, h minus 2k squared. We need to worry about this and the y2 minus y1 part. So first of all, the y1 square plus y2 square plus y1 y2, this term can be obtained if we square this expression, correct? So if we square this expression, we get y1 squared plus y2 squared plus 2y1 y2, which is equal to 4k squared. Now this y1 squared plus y2 squared, nothing to worry about, because y1 squared plus y2 squared is x1 plus x2 and x1 plus x2 is 2h. So here directly we can say this is 2h. And hence we are getting an expression for y1 y2, which also is quite important. You will see why. Which gives us y1 y2 equals 4k squared minus 2h by 2, which is 2k squared minus h. So y1 y2 equal to 2k squared minus h is quite an important expression. Why so? Because we are actually also looking for y2 minus y1. So observe that y2 minus y1, don't forget we have generalized that y1 is less than y2, so y2 is greater than y1. So y2 minus y1 will be square root over y2 plus y1 whole squared minus 4y1 y2, which is square root over y2 plus y1 whole squared would be 4k squared minus 4 times y1 y2 we just derived 2k squared minus h. And hence we get y2 minus y1 as, if you bring the 4 outside, it's simply 2 root over k squared minus 2k squared plus h. So h minus k squared minus 2k squared is minus k squared. And this is again another important expression to be replaced. So now we have y1 y2, we have y2 minus y1. Therefore this y1 square plus y2 square plus y1 y2 can also be obtained from here, and the y2 minus y1 has also been obtained. Therefore from here we continue. Delta equals y2 minus y1 is replaced by 2 root over h minus k squared multiplied by y2 plus y1 would be 2k plus, this is h minus 2k squared, h minus 2k squared minus 1/3 of y1 squared plus y2 squared is x1 plus x2, which is 2h. So this is 2h plus y1 y2 is 2k squared minus h. 2k squared minus h. Simplifying, we get delta equals 2 root over h squared minus k squared multiplied by, I think I missed something here. So here when I integrated, there was ky squared. So this is k times y2 squared minus y1 squared. And here when I take the y2 minus y1 common outside, I forgot to put the k back here. So there's supposed to be a k over here, which I missed earlier. And now this k times y2 plus y1 becomes 2k times k, which is 2k squared. And proceeding, the 2k squared, they will get cancelled. We'll be left behind with h minus, this is 2h minus h, which is h plus 2k squared by 3, which becomes 2 by 3 times, this is 3h minus h, so h minus 2k squared, h minus k squared. So this is root over h squared minus k squared times 3h minus h is 2h minus 2k squared. To bring the 2 outside, this is 4 by 3 root over h squared minus k squared multiplied by h squared minus k squared. Here also I made an incorrect replacement. This is 2 root over h minus k squared. So this is h minus k squared. So the squares will be removed from here, which gives us, this is h minus k squared root over times h minus k squared. So that would be h minus k squared raised to the power 3 by 2. And now this is the area as given to be 4 by 3 in the problem. And this is the significance of this 4 by 3 term. The 4 by 3 simply gets cancelled. And now this will simply become, by squaring both sides and then taking cube root, h minus k squared equals 1. 1 square is 1, 1 cube is 1 as well. Obviously, we are not considering complex numbers. And hence, finally, y squared equals x minus 1 turns out to be the locus, that is the curve S here. Now that we have found out the curve S, we can easily verify whether options A and B are true. So for option A, observe that 4 comma root 3, if we substitute here, y squared becomes root 3 squared, that is 3, and 4 minus 1 is 3. 3 equal to 3 gets satisfied. Definitely option A is correct. For option B, 5 comma root 2. If you put y equal to root 2, it becomes y square becomes 2, and x minus 1 becomes 5 minus 1, 4. 2 equal to 4 is incorrect. So definitely option B is wrong. So you got, out of the first two options, you got one of them correct. Now for the next question, or the next part of the question, area of R, this is comparatively and hopefully quite simpler. In this particular case, what you do is you sketch the curves to get the region. R denotes the region lying in the first quadrant enclosed by the parabola y squared equal to x. So this is the original parabola. So it's given y squared equal to x. And the curve S. So of course the curve S we have obtained as y squared equal to x minus 1 simply implies that the curve is shifted to the right hand side. The y squared equal to x is shifted to the right hand side by 1 unit. So here this is the parabola y squared equals x minus 1, and the lines x equal to 1 and x equal to 4. So x equal to 1 implies this is the vertex 1. So of course x equal to 1 implies this line, and x equal to 4 is somewhere here. This is x equal to 1. This is x equals 4. This is the origin. And don't forget, lying in the first quadrant, which implies only this region is important. Area enclosed by this green parabola, the orange parabola, and these two lines. This is the area in question. So what we do is we integrate first of all the green parabola, and then from that we subtract the orange parabola within the limits 1 to 4, and that's it. So our answer would be integration from 1 to 4. The green one is y squared equal to x, so y equal to root x. This time we are integrating with respect to x, don't forget. Minus the orange one is simply y equal to root over x minus 1. And integration root x is x power half plus 1, x power 3 by 2 by 3 by 2, 2 by 3, x power 3 by 2. Within the limits 1 to 4. minus, this is again 2 by 3, x minus 1 power 3 by 2 within the limits 1 to 4. Substituting the values, 4 to the power 3 by 2 would be 8 minus 1, 7. 7 2s are 14 by 3 minus 4 minus 1, 3. 3 to the power 3 by 2 is 3 root 3, and putting 1 here gives you 0. So 2 by 3 times 3 root 3 is 2 root 3. So quite easily you get 14 by 3 minus 2 root 3 as the correct answer, which means option C is correct, and previously we got option A correct. So finally option A and option C turn out to be the correct answer. See, this was definitely, I don't disagree that lengthy solution. But again, understand something, that out of so many questions, and of course when something is being explained with all the nuances involved, it takes time to show a solution. So never judge a certain question based on how many minutes you see on a YouTube video, that how many minutes it takes to explain the solution to you. Because what happens is, once you are solving the problem on your own, under pressure, under time constraint in the examination, a lot of these explanations, etc., they automatically take place in your head. And also there is speed that comes into play. You are not really required to explain every step to somebody. You can very easily skip a lot of steps in your mind if you are a very good human calculator. And that comes only with practice. So keep practicing more and more problems and get better at problem solving, and never forget to enjoy the journey of solving a problem. I'll see you in the next video.